Let's see here. Who is up next? Okay. And let's go ahead and make sure that people can join me online. Okay, there we go. Perfect. Oh, hey. Sorry I didn't see you there. Yeah, I was just getting my online room ready. That way people have the option of joining the tutoring session in person, or you guys can drop by via Zoom in case you have any questions. So I think it's always great to have both services available. So I will be checking periodically over here just to make sure that I don't have any questions. But yeah, that being said, what can I do for you today? Yeah, having a little bit of trouble with physics. Totally understandable. Yes, it's definitely a challenging course, I will say. Yes, it requires a good deal of dedication, studying, especially when we're talking about mechanical physics. You're a STEM major, is that right? Yeah, okay. Yes, I think I've seen you in class, but I just wanted to make sure. Okay, perfect. Well, let me go ahead and actually pull up right here the chapters that you guys are working on right now. And is there something in particular that's getting you stuck, or that's making you feel a little bit frustrated? Or do you think you just maybe need to like review? You're getting stuck. Yeah. Okay. Well, I tell you what. I'm gonna go ahead and pull up the chapter that you're working on. And let me go ahead and grab a sheet for us to work with here in case we need to work out any problems. But the good thing is that you are coming early on in the semester, so we're able to rectify anything that you may have questions with. Now, mind you, I am a student as well. Okay, I do pretty alright with physics. And your class in particular, since you're taking Physics 100, which is in the introductory mechanical physics course, so I don't see myself having an issue. But if there is something that I cannot answer right away, I will definitely write it down. I have my own notebook where I will write down any questions that I need or that I didn't know, and once I get to my professor, or once I get in touch with somebody a little bit more knowledgeable, then I can go ahead and answer that, and I can get back in touch with you. And I usually just send you an email. I'll send you an email, and depending on what kind of problem it is, I'll take a picture of my work and I'll explain it, or I'll just kind of copy it, or type it out, whatever it is, depending on what it is. But that's what I've historically done in the past whenever I can't find an answer. So just rest assured that regardless, you will leave today a lot more confident in physics. And by the off chance that I can answer some obscure question, then you can expect to have that in your email box. Hopefully within 1 or 2 days. I try and be as fast as possible about it. If possible, I try and do it the same day. If I see any of the appropriate professors, but if not, I'll definitely try and do it the very next day. Alright, sound good? Great. So let me just make sure that nobody's logged in over here. And okay, looks like we do have somebody logged in. And can you hear me all right over there? Okay, wonderful, wonderful. And yeah, that's okay. You can, yeah. Let me, there you go. Yes, that is absolutely okay if you want to type it out. Okay. Yeah, so I'll of course be talking to here. You can hear me fine. Perfect. Okay. And I'll check if you have any questions periodically over here on chat. And if it's something urgent, if you need me to stop, then I'd just suggest that you just unmute really quick if you need to or something. Okay, so you are covering chapter 3 of mechanical physics. Why don't we start with displacement? And by the way, if you hear my voice a little bit lowered, that's because we are of course, or us too anyway, we are in the library, and at the moment we do have quite a lot of people having tutoring. It seems that this year we've had a much better turnout of students, which is great. So we're pretty saturated at the moment, and yeah, so everybody's like very busy. Everybody's got their own thing going on. Fortunately, I was able to get us a room here, but still it tends to get a little loud in here with the acoustic, so I tend to just keep my voice a little bit lower. And if you need me to speak up or repeat anything again, like I said, just let me know. And alright, so do you guys know what displacement is? No. Yes. Great. Yes, absolutely. So the change in position. The change in position is known as displacement. Right? So the word itself, displacement, implies that an object has been displaced, right? So that is a great definition for displacement. Now, one thing to know is that the displacement is a vector. It's a vector quantity. So it is not a scalar quantity, it is a vector quantity. Do you guys know the difference? Yes. Okay, a little bit. Yes, there you go. That is a great example. Yeah, exactly. So something scalar would be like speed, right? Like if I said, I was driving 50 miles an hour. That is a scalar quantity because I'm just giving you speed. Nothing else is really required. Now, a vector quantity would be if I said I was driving 50 miles due north. In that case, I am also indicating direction, and that is a vector quantity right here. Right there, sorry. And it's very important to distinguish between the two. I know that, let me just double check here. Let me double check. I want to say, oh yes, if you actually take a look back on chapter 2, you can actually see that we have a fairly good list of, I think it's here. Let me see. I think they had a pretty good list of different examples that showed you scalar quantities versus vector quantities, and it's just kind of nice to go through them and understand exactly what the differences are, because as we go forward in the sections, we're gonna sort of assume that you've already gotten the difference. So I wasn't able to find it right here. Oh yes, good job, thank you so much. Okay, there you go. So it's actually going to be, yeah, so chapter 2, I was just looking in the wrong section. Yep, there you go. Okay, so you see it. Let me actually go ahead and I'm gonna go ahead and add this file right here onto our group, just in case. Okay, there we go. Can you see it? Okay. Okay, so is it a little bit more clear now on what the difference between scalar and vector quantities are? So if I say speed, scalar, displacement, vector, velocity. Awesome. Yes, so velocity, acceleration. We'll deal just a little bit with force probably, but not too much right now. I think so far in this chapter we've been seeing displacement, velocity, and acceleration, but not too much on force, other than acceleration due to gravity, which it's just part of the acceleration. It's not really touching onto the actual force. Anyway, we're just dealing with what is known as kinematic physics. Kinematic physics deals with motion. Okay, and anyway, so now that we have distinguished the difference between vector quantities, scalar quantities, now we know speed, displacement. Let's see. There we go. So I want you guys to look at this first example right here, the first example from the book, and you can see how we start at the point of origin and they travel 5 meters east. Do you see that? Yeah. So they travel 5 meters east, and then, and this is just along a straight line. So we're just talking regular road, right? Straight line, nothing funny. They travel right back the same 5 kilometers, 5 kilometers back, and they end up at their initial position. So what is the displacement and what is the total distance traveled? 10. 10 is the displacement. Not quite. Do you know why? Do you guys know why? I know, it's a little confusing. So basically displacement only really takes into account your final position and your initial position, right? So if you started at home and at the end of that journey you ended up right back at home, then you would have a displacement of 0. Because displacement, essentially, we're not really factoring in how far you went, how long it took, nothing like that. Whenever we're talking about the displacement, we're just talking about your final point, and how far away that is from the initial point. Okay, so in this case, it's 0. Now, the total distance traveled is, in fact, 10 kilometers, right? Because you did go 5 kilometers one way and 5 kilometers the other way. Yeah. Does that make sense? I know. Yes, and you'll see that the textbook denotes displacement as the delta x symbol. So whenever you see that, we're talking about displacement, and you'll see various notations throughout the book for different things. I very much enjoy learning new notations, understanding what they mean, because there are so many of them, and I think it looks cool. I think it makes you look really smart, right, when you know all kinds of fancy Greek letters and what they mean. But more importantly, they're going to help you stay organized a little bit better, because you're not having to write out all of these things like the displacement between these 2 points is da 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 da, right? You can just summarize everything into 2 characters, basically. And yeah, so I think it has its advantages. So definitely make sure that you guys are studying these little symbols, right? So do you guys normally take notes? I know that you guys are taking notes right now, which is amazing. And actually, let me actually show you guys really quick how you might draw that. So we're going to forgive the terrible handwriting, and this is very small, right? Very small. But you'll see that I put 5 kilometers, the positive 5 kilometers, with an arrow facing east. And then I drew another arrow facing west, and I put negative 5 kilometers. And in this case, we're basically just talking, what I'm saying is exactly, right? So the negative is just implying that we're moving 5 kilometers in the opposite direction. That's great. Yeah. I actually took some notes, and I wanted to show you guys. Here you go. So we'll get into this in just a second, but here's just an example of one way that I like to organize my notes. It's not the best, but you can see I have my tabs up here. I have my tabs to keep up with the class, which is something that I recommend that you guys do. It's very much helpful, especially later on as you get further into a semester. You're not wanting to have to literally flip through a million pages of notes, because if you are consistently doing this right, then you're probably going to have a lot of notes, right? And same applies for math and a few other subjects that my notebooks are just stacked. So yeah, and then what I like to do is, of course, highlight the important points. I went a little bit different. I usually do the yellow, just basic yellow highlighter for definitions, but I changed it up a little bit on this book, or on this notebook, and I started to like box in the definitions instead. So like you can actually see here, for example, the definition of average velocity. I kind of box that in green, and then I'm using blue for the examples and the answers. Yes, absolutely. Here you go. See here is a so this is where it starts. And this is chapter 3 right here. Here you go. Oh yes, yeah, go ahead. So I always like to have a notebook with me because it's for you guys to take a look at, and I'll snap some pictures of it, and I'll make sure to upload those to the group. Okay, sweet. Yeah. And okay. Yeah. Okay, yeah, no, thank you for, yes, absolutely, thank you for asking that. So let me go down here just a little bit, and here we go. So you had a question on gravity, right? Okay. Okay, so this is a good one. Thank you for that question. So basically, what happens is that you have acceleration due to gravity, and that is a constant. You guys will see the G symbol on there, I believe, on section 3.5. Yeah, 3.5. You guys can actually see right there that you'll have your symbol, and it'll actually show you the value, which is the textbook, I believe, averages it out to 9.8 meters per second squared, but depending on several geographical factors, it can vary between 9.78 and 9.83 meters per second squared, and that's what we define as the acceleration due to gravity. So the way that we can use that for that question of what is the acceleration as you throw a ball, or when you throw a ball up. So remember that at the very top, when the ball reaches maximum height, the velocity is 0, but the acceleration is still the same, right? That's why it's a constant. It's constantly the 9.8 meters per second squared. So yeah, just go ahead and change that answer. I understand. I totally understand. I know it's a little confusing, but yes, remember that is referring to the velocity, because if you think about it, right, you have this we'll use this, right? You have this ball, and it's just going all the way up, and then at some point it's going to stop, and then right before it drops back down, and at this point the velocity is 0, but it's always being pulled down by the force of gravity, right? So it would still have that acceleration of 9.8. The only difference now is that as it goes down, it is going to be the object, or the motion of the object will be going in the same direction as the force of gravity. Did that make sense? Okay. Yeah, no. Awesome. Well, I'm glad I was able to answer your question. Thank you for stopping by. Okay. Alright. So what about you? Did you have any other questions on any of it? Oh, yeah. Yeah, absolutely. So let's go back chapter 1, okay? So what is it that's stopping you on chapter 1? The units. I see. So, one thing that I would do, and I'm going to also send this to the group here, that way you have like the picture, because I know it can sometimes be a little bit tedious going back and forth trying to find them, or even if you take a picture, really, even if you take a picture, that's also really good. There we go. So metric prefixes, I think metric prefixes, really the difficulty is that, given that, you know, that's not or that's not what we're used to in school. We're taught the U.S. customary system, and of course that's, you know, miles and feet and all that good stuff. So it can be a little shocking, you know, to just start using a whole bunch of different metric prefixes all of a sudden that we're not used to. But here's actually let me show you. Here's actually a really good list that I like to have, and it's something that I would actually really recommend for you to keep on your binder or something like that, just so that you can visibly see it. Because I know that historically this has been asked on the first exam and then also on the final exam, which is cumulative. So just really make sure that you are familiar. I'm not saying you have to know every single one. Like you may not see 10 to the negative 18 power, for example, like ADO or hexa, which is 10 to the 18th power. But then again, you might, right? And for sure, you'll constantly see centi, milli, kilo, micro, a few other ones. So just be aware. I would have most of them memorized, to be honest. Yeah, but honestly, on that one, let me see your work. Nah, this isn't too bad at all. Yeah, your conversions are actually really good. Yeah, if you actually look at mine for chapter 1, there you go. You can even see some of the work that I was doing on some of these. See, some of these conversions, and they're no better than yours, so really good. I think what's tripping you up is whenever you're having to do multiple conversions. That's where I see that you're having a little bit of problem doing it twice, right? So my recommendation would just be to completely do one. I know that usually on textbooks you'll see them written out as they'll write out the entire conversion and cancel out everything in like one go, but I would really do it one at a time, equal it all up, and then do another conversion separately. I think that way it's going to be a little bit more organized with you, right? Just like take baby steps. Textbooks sometimes throw a lot at you, assuming that you already know how to do certain things. Yeah, of course. No, well, that was a pleasure to help. Thank you for coming in. Remember that my review times are going to be the same for the rest of the semester, so if you have any questions, just stop on by. Yeah. Alright, absolutely. I'll see you on the next one.